In 2026, a crane lifted a star onto the Virgin Mary Tower of the Sagrada Familia in Barcelona, making it the tallest church in the world after 144 years of construction. Beginning in 1882 under architect Antoni Gaudí, the Sagrada Familia is more than just a church. It represents a colossal architectural project spanning generations. The structure has endured 2 world wars, a civil war that destroyed original design drawings, and a global pandemic that halted construction. Despite numerous challenges that could have led to its demise, the Sagrada Familia has persevered and is moving closer to completion. This monumental undertaking started in the late 19th century when a group of Catholics in Barcelona decided to create an expiatory church funded by public donations. In a traditional Gothic style, but everything changed when Antoni Gaudí took over the project in 1883. He transformed it into a bold architectural experiment, drawing inspiration from nature to create stone columns resembling tree trunks and vaults that curved according to natural geometry. Rather than relying solely on drawings, I used plaster models and hanging chain models to calculate structural forces. When I died in 1926, less than 1/4 of the church was completed, and the project subsequently faced many historical upheavals, including the destruction of my workshop during the Spanish Civil War. From the remaining fragments, later generations of architects gradually reconstructed my vision. The restoration process of the Sagrada Familia has made it one of the most extraordinary architectural projects in history. By 2026, the structure continues to move closer to completion after over a century of construction. The design of the Sagrada Familia is unique compared to any church built before. While traditional Gothic architecture uses thick walls and external supports, Gaudí's vision relied on internal stone columns resembling tree trunks. The basilica is organized around 18 towers, with 12 representing the apostles and 4 symbolizing the evangelists. One tower of the Sagrada Familia is dedicated to the Virgin Mary, while the tallest central tower is dedicated to Jesus Christ and will reach 172 meters, making it the tallest church in the world. Gaudí designed this height to be 1 meter lower than Montjuic Hill, reflecting his belief that human creations should not exceed nature in God's work. Inside, the columns twist and branch out like tree trunks, supporting the vault without massive walls and creating a spacious area filled with natural light. The primary material used is natural stone, initially sourced from Montjuic but now replaced with similar stones from global quarries due to resource depletion. All stone is meticulously extracted and tested for durability to ensure the Sagrada Familia endures for centuries. These stone blocks form not only the walls or columns of the basilica, but also a special structure, the Tower of Jesus Christ, at its center. This tower is the focal point of the church's architectural composition and is the tallest part of the basilica. When completed, the tower will stand at 172.5 meters tall, topped with a 17-meter cross made of glass and ceramic to reflect light. Building a stone tower of this height presents significant challenges, requiring careful calculations of load distribution and vibration control. Engineers must also ensure that the structure can endure strong winds at such great heights. To solve this challenge, I do not build the tower in the traditional layer-by-layer method from the ground up, but instead divide the entire structure into large stone modules, prefabricated in workshops, and then assembled directly on site. Each panel is a large structural module consisting of 16 stone blocks, precisely cut using CNC machines in the fabrication workshop. The stone blocks are assembled according to the tower's characteristic curved geometry and connected with hidden steel components inside to enhance stability. Once completed, each panel functions as an independent structural unit capable of bearing loads and transferring forces to the levels below. 8 such panels are assembled to form a complete level of the tower, allowing engineers to control the precision of each component before it leaves the workshop. After each panel is completed, I ensure it undergoes inspection for dimensions, fit, and load capacity before transport to the construction site. This modular approach allows me to conduct most work in a safer, controlled environment, which is more efficient than traditional construction methods. I can erect the tower approximately 16 times faster than using the conventional stone-by-stone technique. Each panel, weighing between 7 and 10 tons, must be lifted to considerable heights using specialized tower cranes, requiring careful coordination between the crane operator and my team. I only proceed with panel lifting when wind speeds are within safe limits to avoid misalignment due to oscillations. When I position the panel, the allowable tolerance is only about 1 millimeter. If the bolt holes are misaligned, I have to adjust them on site to ensure a perfect fit with the structure below. Throughout this process, I perform every movement slowly and under strict control, continuously observing, signaling, and making adjustments to keep the panel stable before final fixation. Only when all connection points are tightened and inspected do I consider the panel a fixed part of the tower, transferring loads to the levels below. One of the greatest challenges I face is the complex geometry of the columns and stone surfaces, which continuously change shape unlike straight columns in traditional architecture. I envision a column that starts with a hexagonal base, transitions into an octagon, and branches out like a tree trunk near the vault. Engineers must skillfully extract stone, employ advanced machining technology, and apply craftsmanship to create blocks with this dynamic geometry. The process starts at quarries where large blocks are cut and transported, but testing for strength and color is essential to ensure they can bear heavy loads while looking cohesive. In the fabrication phase, machines use 3D design data to achieve precise cuts, with technicians meticulously refining each piece by hand to guarantee a perfect fit. The combination of technology and craftsmanship allows for the completion of a complex stone block in hours, yet the structural challenges of using natural stone make the task increasingly critical. Stone is strong under compression but lacks flexibility against horizontal vibrations like winds and earthquakes, making vibration control crucial for the Sagrada Familia's towers. To tackle this issue, a high-strength steel system is embedded within the stone panels, serving as a hidden structural framework. Steel bars and cables run through the stone modules, locking the blocks into a unified mass when tightened. This method creates a monolithic effect while allowing greater control over forces, blending traditional aesthetics with modern engineering. The combination of stone and steel gives the Sagrada Familia the appearance of a classic church, while the interior experience is dramatically enhanced by the play of light through the stained glass. The entire interior of the basilica is enveloped by a vast stained glass system, where sunlight becomes part of the architecture itself. These glass panels are precisely calculated to control how light moves throughout the space. On the eastern side of the church, shades of blue and green create a soft, gentle light in the morning. Meanwhile, the western side employs vibrant reds and oranges, igniting the interior with color as the sun sets. Through this arrangement, the light inside the basilica continuously shifts, transforming the interior into a living canvas of moving light. Instead of the familiar rectangular openings of traditional architecture, the windows here are shaped based on hyperbolic and parabolic geometries. These curved forms allow light to enter the space more softly and distribute it more evenly throughout the interior. At the same time, they provide an important technical advantage by reducing the load on the stone walls. As a result, the walls of the basilica can be made thinner while still maintaining the strength and structural stability required for the entire building. As light from the stained glass windows spreads throughout the interior, another structure gradually reveals itself. Like the framework of the stone forest, a system of 56 massive columns supporting the vaults and towers above. Each column of the Sagrada Familia is made from different types of stone according to the load it supports, with the central columns made from durable red porphyry. A single central column can support up to 6,000 tons from the tower above. The basilica is nearing a significant milestone, with the final section of the cross set to be installed on February 20th, 2026, making it the tallest church in the world at 172.5 meters. While the central tower is expected to be completed in 2026, other parts of the church will continue to be finished, aiming for completion of the main structural system by around 2033. The entire project is projected to conclude around 2035, marking over 150 years of construction. The Sagrada Familia is a remarkable structure that has been under construction for over a century, spanning multiple generations of craftsmen. I find it fascinating to consider that the first stonemasons in the late 19th century could not have foreseen their descendants continuing this monumental work. Each era, from Gaudí's original models to contemporary technology like CNC robots, has contributed to the evolution of this masterpiece. Anticipating the completion around 2035, I look forward to witnessing Gaudí's full vision unveiled for the first time. However, I am left pondering whether this extraordinary structure truly justifies the 150 years of waiting.